All right, let's look at 5.1. 5.1 talks about quadratic functions, looking at how to graph them, what's my domain, what's my range, how do those work, how do I find them without having to draw things, okay? So quadratics are different than parabolas, but they're also the same, and so they usually get interchanged a lot. Quadratic functions are the quadratic itself, okay, refers to let me get a color that actually writes. The function of a quadratic. Okay, the actual f of x equals part. That is a quadratic. A parabola actually refers only to the shape of that graph. Okay, so that U-shaped curve, that is called a parabola. If the parabola is facing upwards, like the one in this picture, our vertex is a minimum. If a is negative, then that means our parabola gets shaped upside down, and so our vertex becomes a maximum. Okay? And that will come into play when I'm trying to determine range. Okay, when we try to do range without having to graph it, that's where that's going to come from. Is that parabola facing up or is it facing down? Okay. The x-intercepts are found from the graph or through factoring. We're not going to go over that. So we did a whole thing on factoring. You can go back, you can look it up and review it. Factoring is important, but we're not going to recover it in this class because we've already, or in this section because we already have. Okay, the y-intercept is either found on the graph or by plugging in x equals 0. Now these have an axis of symmetry, and that is the same thing that symmetry has always been. If I was able to pick up this graph and fold it on that line, I would perfectly fold that parabola in half. And so it's called the axis of symmetry. Now be very careful with this. The axis of symmetry is a line. So if they ask you for the axis of symmetry, your answer needs to always include that x equals. It's a vertical line, and so I have to write it as the equation of a line. If you just put 2 or 7 or whatever it is, it's going to mark you wrong. So make sure that you are using the line for the axis of symmetry. Okay, quadratics come in two basic forms. You're going to have your general form, which is f of x is ax squared plus bx plus c. To find the axis of symmetry, or the x coordinate for the vertex, we take negative b over 2a. Now I did not just make that up out of nowhere. It is the first part of the quadratic formula. The quadratic formula takes the vertex, it finds the vertex, and then uses symmetry, that's what the plus and minus is, to go to the left of the vertex a little bit, and then to the right of the vertex the same distance. Okay, so the vertex is part of the quadratic formula, so that negative b over 2a comes from there. General form, we prefer for factoring. If you're not going to factor, general form is really not that useful, unfortunately. Okay, we have it, we can use it. It's not great unless I'm trying to factor. Okay, your standard form, which I learned as vertex form, so I apologize. The reason it's in parentheses is because I can't help but say it that way, so I apologize ahead of time. Most sources online actually call it vertex form and not standard form, so just kind of be aware of that as you look things up. This is actually the preferred form for graphing. It's easier to graph from vertex form than from general form or from standard form. Okay, your vertex, the reason we call it vertex form is because your vertex is h and k. It's those transformation things again. So back to chapter 3 where we were talking about transformations. The transformations tell me where is the vertex. And once I have the vertex, we can use that a value and figure out how to sketch this graph. Okay, and we'll get to some of that a little bit. Okay, the domain of every quadratic is negative infinity to positive infinity. Flat, straight rule. It does not matter if it's transformed, it doesn't matter what form it's in. If you can recognize that it's a quadratic, that is your domain. Okay. Now, the range depends on whether or not you have a maximum or a minimum. If you have a negative a value, remember this parabola is going to face down, and so your range is going to go from negative infinity, that's the smallest number on this graph, up to that vertex. Okay, specifically the y value, because remember, domain deals with the x values, range deals with the y values. So when we're looking for range, we want y values. Okay. If that parabola is, or if a is positive and that parabola faces up, and we have a minimum, then our range starts at the bottom, starts at the minimum, and moves its way up. Okay, so finding range, we use the x value of the vertex to find our axis of symmetry. We use our y value of the vertex to determine range. Okay, domain is always negative infinity to positive infinity. No difference, doesn't matter. Anything else is unimportant. Okay. All right, now because one of the forms is better for factoring and one of the forms is better for graphing, we often need to swap between them. Okay, if I go from standard to general form, all I really need to do is multiply everything out. Just multiply it out and it'll work out. Okay, so I'm going to take x minus 2 squared plus 5. This gets FOILed or distributed, okay, and that becomes x squared minus 4x plus 4. And then I have this plus 5 still. So this function in general form is x squared minus 4x plus 9. Okay, really straightforward. Grab it, multiply it out. Now you're in the right form. For f of x is negative 2 times x plus 4 squared minus 6. There is a really, really, really common mistake, okay? And that common mistake is to try to put that 2 into the parenthesis. You cannot do that, okay? Remember your order of operations, parentheses, then exponents, then you can multiply. So before I can multiply, we have to take care of that exponent. So I have to FOIL this first. So this is going to be negative 2 times x plus 4 times x plus 4 is going to be x squared plus 8x plus 16 minus the 6 on the end. And then we've got, now I can FOIL it through. And another really common mistake is to put that 2 on this minus 6 at the end. It only goes to the parenthesis that it's touching. Okay, so don't multiply it by the minus 6. So I have negative 2x squared minus 16x minus 32 minus 6. So f of x is negative 2x squared minus 16x minus 38. Okay, that last one I've got f of x is 1/2 times x minus 2 squared minus 4. So we're going to FOIL out, distribute out that x minus 2 squared. So I end up with x squared minus 4x plus 4 minus 4. So I get 1/2 x squared minus 2x plus 2 minus 4, And finally, 1/2 x squared minus 2x minus 2. Okay, so all the way into general form, it has to be multiplied out. You should only have 3 terms or less, and you're good. Okay, now to go the other way around, to go from general form to standard form. Remember way back in chapter 3, we looked at completing the square, and we said, or I said, there's going to be one other time that you need to know how to do this. Well, the time has arrived. In order to go back to standard form, we have to complete the square. Okay? So, if I start with f of x is x squared minus 2x minus 3. Now, the last time we completed this square, we took that 3 and we would move it to the other side. The reason I can't do that this time is because instead of having a number over there, I have a name, right? F of x is the name of something, and I can't take a name and add 3. That doesn't make any sense, okay? So what we do instead is we just kind of treat it a little bit different. We're going to take this x squared minus 2x, we're going to leave space, and then push that negative 3 over to the right. It's not gone. It's still there. We're just going to ignore it for a little bit. Okay. Now we're going to complete the square. So completing the square, I take b over 2 and I square it. So I get negative 2 over 2 squared, which is going to be negative 1 squared or positive 1. Okay. And again, the last time we completed the square, we added that 1 to both sides. I can't add 1 to a name. So what we do instead is we add it and then we subtract it. And so essentially what we're doing is we're adding 0. It looks weird, but we're just adding 0, which doesn't change what we're looking at. Okay. Now this forces these first 3 terms to factor into x minus 1 squared. And then I still have this minus 1, and I have the minus 3. So I get x minus 1 squared minus 4. Okay. My vertex is at 1, negative 4. I know the domain has to be all real numbers because it's a parabola. It's got to be all real numbers. I have a positive value out front, which means this is a minimum. And that should be in parentheses. So my range is going to go from negative 4 to positive infinity. Okay, and we would do the same thing on the last 3 examples. I just realized I forgot them. I apologize. Okay, so now that we've got that, pause it if you need to. I'm going to erase. Okay, f of x is 2x squared plus 12x plus 19. Okay, we're going to do the same thing. We're going to say I have 2x squared plus 12x, leave some space, and put that 19 outside. Now what I'm doing is I'm going to work only in the parentheses, same as last time. I'm going to ignore that 19, and I'm just going to work inside those parentheses. Okay, so looking at just what's in there, completing the square only works if this number is a 1. So I have to factor out a 2. So this becomes 2 times x squared plus 6x plus 19. Okay, now I can complete the square, so I'm going to take 6 over 2 and square it. So I get 3 squared, which is a 9. So we're going to add 9 and then subtract 9. And these first 3 terms are going to factor into x plus 3 squared. And then I've got this minus 9. And outside of that, I have a plus 19. Okay, it is very common here to add 9 and 19. Again, you cannot follow your order of operations first. This 2 has to get distributed to both of those terms because it's multiplication, and multiplication has to come before I add. So this is going to be 2 times x plus 3 squared minus 2 times 9, which is 18, plus the 19 at the end. And now that I've multiplied it, I'm allowed to worry about adding those together. So in vertex form, this is going to be 2 times x plus 3 squared plus 1. So our vertex is at negative 3, positive 1. The number out front is positive, so this is a minimum. Our domain is all real numbers. And for the sake of space, I'm just going to not write it. Okay, it's negative infinity to positive infinity. And our range, because this is a minimum, is going to go from the y value of the vertex up to infinity. Okay. Again, pause it because I'm going to erase. All right. If f of x is negative 3x squared minus 6x plus 2, pause it. See if you can do it on your own. Try it. There's no harm in it. Try it and see if you can get it, okay? Then push play and walk through it. We're going to move that 2 to the side. So I've got negative 3x squared minus 6x plus 2. And then we're going to factor out that negative 3. So I've got x squared plus 2x plus 2. And once we've got that out of there, now we're going to complete the square. So I have 2 over 2 squared, which is 1 squared, which is a 1. So we're going to add 1 and subtract 1. So I've got negative 3 times x plus 1 squared minus 1 plus the 2 outside of the parentheses. Distribute that negative 3. So I've got minus 3 times x plus 1 squared. Negative 3 times negative 1 is plus 3. And then plus 2. So our function in vertex form is negative 3 times x plus 1 squared plus 5. So that means that our vertex is at negative 1, positive 5. The number out front is negative, so this is a maximum. Okay. Our domain is all real numbers because it's a parabola, and that's what the domain of a parabola is. Don't overthink it. It's literally just the definition. So our range, because this is our maximum, our range is going to go from negative infinity up to that maximum value. Okay. So swapping between them, a little bit annoying, but that's how it works, right? Just is what it is. If you don't remember completing square, go back, look at your notes from chapter 3, go find a tutor, go find a TA, come see me in office hours, make use of your resources, let's figure it out. All right, I'm going to skip these two. Well, not both of them, I guess. I'm going to skip the second one because we did that in one of the last examples, pretty close to it. So this first one, if f of x is 2x squared minus 8x plus 4. The only difference here between this one and the last one is that I have to find the vertex a little bit differently. So we start by finding the x value of the vertex. So we take negative b, so negative 8 over 2 times a, so I have 8 over 4, which is a 2. And once I have that, to get the y value for the vertex, I'm going to plug that in. So f of 2 is going to be 2 times 2 squared minus 8 times 2 plus 4. So it's going to be 2 squared is 4, 4 times 2 is 8, 8 times 2 is 16, plus 4. So 8 minus 16 is negative 8, plus 4 is a negative 4. So the vertex of this function is going to be 2, negative 4. My domain is all real numbers, and the range is going to depend on whether or not this is a maximum or a minimum. So if we look really closely, the number out front is a positive 2, which means that this vertex is a minimum. And since I have a minimum, that means that my range is going to go from the vertex up to infinity. The vertex is the smallest point. Okay, and then the other one works just like the last example that I gave you. All right, use the vertex and a point to find the equation for a given parabola. All right, so when you are working on these, you should always start in vertex form. Okay, always. It's just easier. The pieces all have places to go. You can do them in general form, but boy, it gets annoying and really weird and difficult, and I don't recommend it. Okay, so start in vertex form. Vertex form says f of x, or we'll call it y, is a times x minus h squared plus k, and we're going to start with it blank. Okay, this is what I consider a blank vertex form. Here, they're telling me y is 0. They don't give me an a value. X is 1. H is negative 2. K is negative 3. So we're going to plug all those in. We're going to solve for a. So 0 equals a. 1 minus negative 2 is a 3. 3 squared is 9. Add 3 to each side. So 3 is 9a. Divide both sides by 9, which means a is 1 over 3. Okay, and then all you have to do to have that equation at this point, all you have to do is rewrite it. So my equation, we're going to change it back to f of x, is 1/3 times x minus negative 2, so plus 2, squared, plus k, so minus 3. Okay, so you're going to use the numbers they give you and find a. Once you have a, you're just going to kind of rewrite that equation so that you have the pieces you need. Okay, now try the next one. If y is a times x minus h squared plus k. So for the next one, y is negative 15. I don't know what a is. X is negative 2. H is negative 1. K is negative 3. So I'm going to add 3 to each side. So that's going to be a negative 12. Negative 2 minus a negative 1 is negative 2 plus 1. So it's going to be a minus 1 squared. So negative 12 minus 1 squared is positive 1. So a is negative 12. So this function is going to be negative 12 times x plus 1 squared minus 3. Right? The plus 1 is because we're subtracting a negative 1, which means we are actually adding. All right, using a parabola, so working backwards. If they give you a graph, all you have to do is read the information. My vertex is going to be 1, negative 4. This vertex is a minimum. It's at the bottom of my parabola, so it's a minimum. The axis of symmetry is the line that goes through the vertex. So it's going to be the line x equals 1. Your zeros, probably should write in something other than green. Your zeros are these 2 points where it crosses the x-axis. So my zeros in this case are negative 1 and positive 3. That's not a coordinate, it's a list. Okay. Your y-intercept is where it crosses the y-axis. So it's going to be 0, negative 3. It's a parabola, so my domain is all real numbers. The range, I'm going to find the smallest y value, which in this case is a negative 4. And then the largest y value, and there's arrows up here, which means it's going to keep going forever. So the largest y value is negative 4, is positive infinity. Okay, and then you would find the equation the same way we did on the last screen. This parabola ends up being x minus 1 squared minus 4. Okay. All right, graphing a quadratic. So what do I do if I need to be the one that draws the graph? Well, I need a couple of things. First of all, you don't need the x-intercept to graph a quadratic. It would be nice if you had them, but you really don't need them to draw a graph. Okay. What we need is the vertex. So we're going to take, this is in general form. So the x value of our vertex is going to be negative b over 2 times a. So negative 4 over negative 2, which is a positive 2. Okay, that means my axis of symmetry is x equals 2. And the x coordinate for my vertex is also 2. Then I'm going to plug that in and get my y value. So f of 2 is going to be negative 2 squared plus 4 times 2 plus 4, which is going to be a negative 4 plus 8 plus 4, which is just going to be a positive 8. So the y value for my vertex is positive 8. So I can graph my vertex, go over to 2, go up to 8. I can plot my line of symmetry so that I know where the symmetry is happening. My y-intercept happens when I plug in x equals 0. So f of 0 is going to be negative 0 squared plus 4 times 0 plus 4, which is 4. So my y-intercept is at 0, 4. So I'm going to go 0, 4. My domain is all real numbers. The range, this is upside down, this is negative, so this is going to be a maximum. And so my range is going to go from negative infinity to positive 8. Now to draw this graph, we're going to, instead of finding x-intercepts, we're going to exploit that symmetry, right? If I go from the vertex, if I go down 4 and left 2, I should also go down 4 and right 2. And once I have those points, That's enough information to get myself a really nice looking sketch of this quadratic. Okay, and that's all you need. Just the x-intercepts are nice, but having them isn't necessarily helpful, especially in this case because they would have been really weird. They would have had square roots in them. They would have been strange and hard to graph. I don't really need them as long as I understand what the symmetry part of this is. Okay? All right, and that leaves your participation quiz. You can screenshot this if you want to. You can just sketch it, turn it in. Just like the last slide, I don't really care about the x-intercepts, but do definitely give me the rest of that information.